Welcome, my dear students. Okay, today we are going to see the numericals based on the previous concept. Okay, first one is this one. Okay, now see, आपल्याला मागं जे काही घेतलेलं आहे त्याच्यावर आधारित न्यूमेरिकल्स आज बघायचे आहेत, लक्षात ठेवा. तर आता पहिलं आपण न्यूमेरिकल बघतो आणि त्याच्या अगोदर आपल्याला सगळ्यात महत्त्वाची गोष्ट लक्षात आली पाहिजे. ज्यावेळेस न्यूमेरिकल लिहायचे आहेत तर त्यावेळेस पहिलं स्टार्ट करायचं आपल्याला विथ given data. Okay, then given data we can write while reading the numerical. Okay, now see how to write. In a machine it was found that the effort had to be moved through a distance of 500 mm. Okay, we know that the notation for the effort moved by a distance obviously denoted by y, and y is equal to given is 500 mm. 500 mm. Okay, now see, next is to move a load by 50 mm. We know that the notation for the load distance moved by the load. Okay, notation for the distance moved by the load is x, that is again 50 mm. Okay, now see, using this machine a load of 10 kilonewton was raised. Load means W. How much given? 10 kilonewton is given, raised by an effort, by an efforts 1.25 kilonewton, means efforts P is given, that is 1.25 again kilonewton. From this given data we need to find out velocity ratio. What is velocity ratio? Velocity ratio is indicated by V dot R. Okay. What is the mechanical advantage? Then M dot A is equal to what? Next, efficiency, eta is equal to what? And last one, the effort for lost in turn. F is equal to what? Yeah. Now, to find out all these quantities, we need to start with the velocity ratio. Then we should know the formula for velocity, right? Velocity ratio is equal to the distance moved by the efforts divided by distance moved by the load, y by x, which is equal to, y is given obviously 500 divided by what, x is given 50. If both have the same unit then there is no problem. If both have the different unit, convert it into the same unit. Okay, हे लक्षात ठेवायचं. जर वेगवेगळे युनिट असतील तर एकाच युनिट मध्ये कन्वर्ट करा आणि नंतर रेशियो घ्या. Now if I take the ratio I will get answer as obviously 0 0 get cancel, 5 take the 50, that is answer is 10, means velocity ratio is 10. Now second thing, we need to find out mechanical advantage. For the mechanical advantage also we have the formula, that is load to be lifted divided by efforts applied to lift load. Then load is given, yes, 10 kilonewton given. Efforts is given, yes, given 1.25. Okay, what is the ratio of these two? You can calculate by the calculator itself. Okay, and the value is what? 8. Value is 8. Okay, कॅल्क्युलेटरचा वापर करू शकता तुम्ही, त्यामुळे कॅल्क्युलेशन साठी तुमचं डोकं लागणार नाहीये, फक्त कन्सेप्ट साठी, फॉर्म्युलासाठी तुमचं डोकं लागणार. ओके, ना नेक्स्ट आहे आपल्याला इफिशियन्सी फाइंड आउट करायची. आणि जर मला velocity रेशो आणि मेकॅनिकल ॲडव्हांटेज माहीत असेल, तर मी इफिशियन्सीचा फॉर्म्युला in terms of mechanical advantage and velocity ratio, I can use. Okay. Then mechanical advantage divided by velocity ratio into 100. This is the formula of efficiency in terms of mechanical advantage and velocity. जर यूज केला तर काय भेटेल बघा, मेकॅनिकल ॲडव्हांटेज इज 8 by obviously velocity ratio is 10 into 100. This gets cancelled. Value is what? 80. And this is the efficiency. Okay. Now, very important. How to find out the effort lost in a friction? For that, we should know formula of it first. Okay. Then, what is the formula? To understand the formula, you should know that the actual efforts is more than ideal efforts. And the difference between actual and ideal is nothing but the effort lost in a friction. म्हणजे ऍक्च्युअल एफर्ट्स हे ऍक्च्युअल एफर्ट्स हे आयडियल एफर्ट्स पेक्षा जास्त असतात आणि ह्या दोन्ही मधला जो डिफरन्स असेल तोच काय असतो, एफर्ट लॉस्ट इन फ्रिक्शन असतो. म्हणजे जास्त आहे त्याबद्दल घ्या, म्हणजेच काय, ऑब्विसली effort lost in friction is equal to the actual efforts minus ideal, okay, which is equal to P as it is minus ideal effort is the ratio of load to be lifted divided by velocity ratio. Okay, now we have all these values put over here. 1.25 minus W is what? 10 divided by velocity ratio again 10. I will get 1.25 minus 1, that is 0.25 kilo is the efforts lost in a friction. The effort lost in a, okay.